There are a couple different ways to write down the equation of a line. A couple different ways to name a function. So this one is called standard form of a line. Oh, by the way, the reason why it's called a linear function is that the word linear, if you kind of cover up a couple letters, it has line right there, just so you can remember. So the standard form of a line is going to be ax plus by equals c, such that a, b, c are integers. A is greater than 0, and then b is specifically not equal to 0. So we can have positive or negative whole numbers. A can equal 0. These qualifiers tell you what you can plug into the standard form of a line. A, b, and c will be some integers when you're looking at a specific example. A can be equal to 0, but it has to be positive. And then b just can't be 0. You have to have something here. What I've found useful for the standard form of a line is that it gives you the intercepts of a line. Now, what are the intercepts? An intercept of a function is when the function kind of crosses either the x-axis or the y-axis. So when the x-coordinate is 0, there's no left and right, so there's just an up and down. So by construction, the y-intercept, meaning it's intercepting the y-axis, that makes sense that that would be there. Similarly, for x-intercepts, you just have a y-coordinate value of 0 because there's no up or down. You can go left and right for the x-intercept, obviously, because we're trying to find out when the function is crossing the x-axis. And this is really easy to do with standard form because we can just kind of cover up the terms, assuming there's here. I'll show you. So 2x minus 3y equals 6. If I wanted to find the intercepts of this line just by looking at its equation, all I have to do is cover up one of the terms, one of the variable terms. Oh, yeah, and x and y in the standard form, x and y stay as x and y until you want to know specifically if a coordinate point is on that line, or if you have one of them and you want to find the other one, then you plug it in for x and y. Otherwise, it stays in x and y because it tells you all of the x comma y's. It tells you all of the ordered pairs that would be on that line. That's why those stay as variables. That always tripped me up. I was like, why do we know stuff about a, b, and c, but not these? It's because it's showing us all of the coordinate points that are on this. Like if we were to take a graph and zoom in a lot, yeah, it still kind of looks like a line, but really there's a line, or any function is made up of infinitely many coordinate points that satisfy this equation. So it's just giving you all of them. So let's find where these intercepts are. So I'm going to cover up the 2x term with my hand. You can do it with your hand, or you can just kind of go like this. If you want to find the y-intercept, then that means that x equals 0 for that coordinate point. Okay, that's pretty simple. We're just gonna simplify for y. Divide by -3, y equals -2. So the coordinate point 0, -2 not only is on this line, the original, sorry 2x. Not only is this coordinate point on this line, it just happens to be the coordinate point that crosses the y-axis. Similarly, we'll do the same thing for the x-intercept, where it crosses the x-axis, meaning there's no up and down, which means there's no vertical displacement, there's no shift in the y direction. Again, we're just going to cover up, that was my elbow, cover up the the minus 3y term, whatever you want to call it. So we're just left with 2x equals 6. So x equals 3. So this coordinate point, 3, 0, not only is on this line, but it's the x-intercept. It's where it crosses the x-axis. What's great about finding out these two coordinate points is that you can graph the function, you can graph the line by just plotting these two coordinate points and then constructing the line that goes through those two coordinate points. It's that simple. You're going to need to know how to draw out and graph functions by hand or by computer. And this is a proper concept. You only need 2 points to determine a line. You can have more than 2 points, but they're kind of superfluous. I can find a third coordinate point on this line. Let's say if x was 1, what is y? I don't know. So 2, 1. So 2 minus 3y equals 6. Subtract 2 from both sides. Negative 3y equals 4. Y equals negative 4/3. So the coordinate point 1, negative 4/3 is on this line. Like I said, any and all coordinate points that satisfy this equation. Oh, I was saying earlier that the a, b, and c can only be integers, but that's fine. But you're gonna plug in some random values and get coordinate points with non-integer values. I mean, that's different from the name of the line. Anyway, I can plot that point, but I kind of already had the line there. That's just kind of confirming that line's there, but it's not giving us any new information. So you only need 2 points to determine a line, and standard form, right away, just kind of looking at it, doing a slight bit of algebra, gives you those 2 coordinate points that are pretty easy to plot, and then just draw the line. Easy peasy.